In this video, I'm going to be doing some work with functions and function composition. Now, some of this is probably going to be old to you, as in you've done it before, and some of it might be new. So let's go ahead and jump right in. We have three functions that have been defined up at the top. We have a g of x function, an h of x function, and an f of x function. And depending on the problem, depends on which one of these or ones we're going to use. Problem number one says f of 3, so I'm going to focus on the f of x function. And f of x is equal to x minus 5. So to find f of 3, I am going to replace x with 3 and simply figure out what 3 minus 5 is. So that's going to be negative 2. Sometimes I've seen students try and say, oh, I have to solve for f, so I need to divide both sides by 3, and my brain says no, don't do it. It's bad, it's wrong. F of 3 is asking for a specific function value given a specific x value. So given the x value of 3, f of 3, what does the function equal? Well, the function equals negative 2. All right, so that's what we're looking for. All right. Number 2, we have h of x minus 4. So we're going to use the h function over here. And so h of x is equal to negative 3x plus 2. You don't have to do this rewrite step. I'm just writing it down because at some point I'm going to be running out of room to see those functions. And so in this case, instead of x, I'm going to replace all of the x's with x minus 4's. So wherever I have an x, I'm going to use x minus 4 and then plus 2, and I'm going to simplify this. So a little distributive property here. Let's see, plus 12 plus 2, so this is going to be negative 3x plus 14. So h of x minus 4 is equal to negative 3x plus 14. There's nothing else to simplify there. We don't know what x is equal to, so we're done. Okay, that's it. All right. Now, number 3 starts getting into what's called a composition, and you may or may not recognize this notation. There's another way to write this. The alternate way to write what's written right now for 3 is to do g of 2 plus h of 2. So basically, I'm telling you for both of these functions, you're going to use x is equal to 2, and because it says g plus h, you're going to add the functions together. So you could start by adding the functions together. So take your g function plus your h function, add them up, and then replace x with 2. Or you'd get the exact same thing if you figure out what g of 2 is, figure out what h of 2 is, and then add those up. I'm actually going to go with the second one for this one. So I'm going to figure out what g of 2 is. So let's see, we've got 2 squared plus 1, so that would be, what would that be, 5? And then separately, I'm going to figure out what h of 2 is. So negative 3 times 2 plus 2, negative 4. And so if I'm asked to add these up, I'm going to do 5 plus negative 4 and figure out that equals negative 1. No, it doesn't. It equals positive 1. Let's take that out. See, it's easy enough when you're working with this. You can just hit the delete button. Yeah, 5 plus negative 4 is positive 1, not negative 1. Yeah, we all make mistakes. All right, so that takes us through the first 3. Let's slide on over to problem number 4 here. So in this case, we've got h minus f of x. So you can do the exact same thing we did in the last problem. We're going to have h of x minus f of x. Now, in this case, there's nothing to replace. We're just literally going to take the h of x function minus f of x and simplify it. So h of x is negative 3x plus 2 minus, now be careful because I want to subtract all of the f of x function. So x minus 5. So I'm going to distribute that negative sign. So let's see, negative x plus 5, and now I'm going to look to combine some like terms. So negative 4x plus 7. We don't know what x is equal to. We're not asked to replace x with anything. So that's problem number 4. We're all done. Problem number 5, I'm, again, not sure if you've seen this notation before. This is read as g of f of 2. And there is a way to write this that's a little bit different, and it would be the g of f of 2. And mathematically, what you want to do is start with this inside set of parentheses here, figure out what that is equal to, and then use that value in the g function. So we're kind of going to start inside and work our way out. So let's start with finding f of 2. So f of 2 is going to be 2 minus 5, so this turns into negative 3. So now instead of f of 2 here, I can replace this with negative 3, and what I'm really now trying to figure out is, well, what's g of negative 3? So g of negative 3 is going to be, in parentheses, negative 3 squared plus 1, so that would be 10. Okay, so you either want to think about working inside out. So you're going to start with this f function first, replace x with 2, simplify, simplify, and then use that value in the g function. Or it's kind of weird if you go with this original function, you're kind of going to read it backwards. So 2 goes in the f function, then that answer goes into the g function. This is truly called a composite function. So it's the composition of the g and f functions. All right. Okay. Now, problem number 6 was already written in that composite function. You could also see this, just so you know the notation, as h of f of negative 1. Okay, just so you understand that this notation is the same as this notation. All right, so starting with the inside, we want to figure out f of negative 1 first. So let's see, f of negative 1 is going to equal negative 1 minus 5, so negative 6, which means now I want to figure out what h of negative 6 is. So h of negative 6 is going to be negative 3 times negative 6 plus 2, so that would be 20. Yeah, 18 plus 2 is 20. All right. So what I'm going to do here is I'm going to go ahead and cut the video. I am going to try and keep this one relatively short. So I went through problems 1 through 6. I will have a second video that goes through 7 through 12, but you might want to give those a try first and then just compare them to the key. And if you have any questions or concerns, check out the video then. If you do have any questions or concerns, let me know. Drop me a message in Canvas